Okay. So for today, the chapter will be the one in the related to the link I've posted in the chat. Did you had any questions on that or?
Can you put that?
Oh, the link I've pasted in the chat.
Oh,
Were there any particular questions? So maybe if I'm touching upon that part, then I can maybe answer the questions or take more time.
Got it.
So I was hoping that Jim would be in the call because
I
mostly
believe Jim said that it is his birthday. I think it's yours too, so happy birthday. But he was more not sure that he might come last week and this week. So I don't know.
Oh, okay. Yeah, it was Julian's birthday last Friday. But
Oh,
from Jim,
sorry.
I'm not sure.
My bad.
Okay, yeah, I kept him in his mind. Yeah, okay. Okay, let's see what we can do. So where I wanted to start is there you go. There you go. It's just quickly with some notes that I scribed in. So starting with the BDS structure, the basic data structure following up on Julian. So we could expect ADSL variables, some variables kept from SCTM. Hi, Julian. And then I'm happy you're in the call. So this introduction, we just started, so this introduction might be helpful. And then we have some common BDS variables. So the treatment variables, visit, parameters, the values that are measured, the baseline value, change from baseline, date, and if date and time is collected, and also flagging which record is the baseline record. So in the BDS data set, you have observed values. So those come from SCTM and are not being modified, the derived values, which are calculations of observed values and imputed values. So if you have missing portions of the observed values, then these can be supplemented with additional data. And so a BDS structure, you can expand it horizontally and vertically. So quickly. So you have, this is mostly the observed values, and these will be the derived values. And amongst them, you will have also imputed values. So you can expand it horizontally, but also vertically. And then, yeah, BDS gets expanded in this way. So that's just briefly an introduction, mostly for Jim, because he was really asking last time, like, what is happening to the data set? So as Julian already touched upon, he gave examples what to expect in ADVS. So we have blood pressure, respiratory rate, heart pulse rate, those type of stuff. And what funny stress last session was, okay, we start with a statistical analysis plan where you might find a mock table, a mock-up. I drafted, yeah, okay, this is a quick draft of what we are going to do today. So this will be the table where you will have the parameter, the visit, statistics, you have the treatment information, and there will also be a test to yeah, give some more information between the two treatment groups, the difference. So for statistics, yeah, what you can expect is just mean, median, standard deviation. And then there's instruction for the programmer, because in this table you want to see weight, height, and BMI by visit. So this information parameter visit you will get from the SCTM dataset, the treatments from the ADSL, and the statistics will be calculated in the table program. And in a few weeks, we will discuss the workflow of creating a table program. Yeah, so that was a quick introduction there. And then I want to go to this page. So this was actually this general BDS page. And then what they were discussing was the vital signs data set. Right. So the first things is indeed call your libraries. And then the important part, that was a funny thing about this page, which you will see in the ADVS page is calling Metacore. Let me get something else. I will go back. Okay, let me go back to this Quarto document. Okay, yeah. So calling your libraries, then calling Metacore. And you really had to look up the ADVS metadata because it's stored in the safety specs. If you would like to have a link to this location, let me know. I will have a look again where it's stored in the pharmaverse GitHub. Yeah, it's there where ADPC is stored too as well. But there you will find a safety spec. So call your Metacore. Yeah, we will mostly need that in the end of the program to make sure that yeah, you can control the length of variables and so on, and the labels. Call your ADSL dataset because we will need some standard variables like the treatment information. Call your VS. The VS dataset has 24 variables and it had almost 30,000 records. So these mostly are some standard SDTM variables, the test, subject ID, the position, location, those are really tailored to VS. So what I did was just a bit looking into the data. What do we have collected? So there are multiple parameters, but we have height and weight. And height is collected at screening 1. And weight is on multiple visit points. And that's good to know because in one of those Admiral functions, you will have to add an additional parameter. You have to take that into account. Oh, this was just something for myself, a bit creating a visual, playing around. Okay, so I'm not taking all the SCTM variables with me, as it's a very basic table. We will need the test, we will need the visit information, and we need the height and weight that was measured and the date, of course. Yeah, so I wanted to have a feeling like how does the data look, and mostly what is date collected or date time collected, so I could see date was collected, and if there were missing values in these variables I selected, so there were none in this SCTM dataset, so that was that's easy. So they go ahead and add the ADSL variables, then they calculate analysis date time. So we want to have the numeric days. The analysis date is numeric, and in SCTM it's the character is stored, character format. So if you want to have more information about the imputation, I would really recommend to look up the function. And what was really nice is that although there's an M or a D mentioned here, if date is missing, if day is missing or month and day is missing, both get imputed. So as a SAS programmer, yeah, what we do is we check the length of a date variable. Is it this only has a year, a month, or and then we assign the imputation or apply an imputation rule. So I was really curious how it works here, but yeah, it works fine. I was afraid that if you have to populate this variable with an M or a D, you really have to know if you need to impute days or months, but it's day and months. And missing is kept missing values. So no partial date values were in the data set. So that was also easy. And I'm not sure why they're using this bottom table.
Just an update. If you go up a little bit, this one, this height imputation, so not height imputation, highest imputation, my bad. Highest imputation, this function, right? Derived dot underscore. This has been recently been updated for keeping the partial dates as it is, if you do not mention. That's a keep a note. I mean, like previously it used you need to have a partial dates and all that. I mean, they never thought of having it, but the recent version of Admiral ha keeps the date as it is. I mean, like say the original dates if needed.
Okay,
Yeah, so just an FYI, that was one of the most recent updates.
great. In 1.3?
I believe so.
Okay,
I do not know the exact version of it, but the dates is a part. I just read what have been updated and all that stuff, and
yeah.
this is one of that. Yeah.
Okay, dokie. So if there would be any imputation, then there is an ADTF. Yeah, this flag variable is created, and then it would be populated with D for day or M for month. Yeah, but this one was empty. Okay, then the params were derived. The parameter code. And then to continue, okay, yeah, height, wait, that went okay. And then so this is the, yeah, okay, then you create the analysis value and analysis value unit. This is just a copy. And then BMI is being calculated. Apparently there is also a derive param BMI function, but then in this example, they used a general function, and it was important as height was collected only on one time point at screening. Oh, well, that makes sense, as in this was not a study with children. So yeah, measuring it at screening would be fine. We have to add a constant parameters. Otherwise, if you don't do it, BMI will not be calculated as height is missing for the other for the other visits. And then looking again at the data, we could see for BMI, okay, it's calculated on multiple time points, right? And otherwise, if the constant parameters would not be there, then for week 2 it would be empty. Okay, then what else do they do? Then they create a, yeah, for the table we also needed to have a analysis visit, the numeric variable. And then, okay, this is what the SDTM variable is, and this is the analysis variable. Quick check, does it look okay? Does it also look okay for the numeric variable? So that's how I went through the code and was checking the data, like what's happening, and also a bit playing around. So as we also, if we go back up to the mock, okay. Did not really highlight it, but I've also added in the mock to calculate the change. So therefore, we need to have the base, baseline variables, and most, I mean, the obvious ones will then be base and the baseline flag. As this, yeah, base type is of interest when you would have a crossover study, when you would, if you would have different phases in a clinical study and you have therefore different baselines, then it's more of interest. So for base type, I've kept it empty for now as it is being used by Metacore. But yeah, so having these general or these more obvious baseline variables, base and baseline flag. So again, just follow the code. Nothing is fancy. I've dropped base type from these functions. And therefore, we could have then the record in the mock, like, okay, what's the difference between, so this is your base, and this is your calculated BMI. Oh no, this is the observed weight at week 24. This is baseline, this is difference. So that's what you would have in the table, this row. That's why we're, yeah, that's why we need this code. Everything is analysis treatments. Everything is analysis variable. So in a BDS, the 0, 1 means the period. So if you're, yeah, in a crossover study, you would have two yeah, well, say you have a drug A and drug B, and then you have a washout period, then you would have 2 periods. But this is, I think this is a very simple design. I assume, I'm not sure. I did not check for it, but okay. Assuming this is the study has only, this clinical trial has only one intervention period. So this indicates the intervention period, and this is one. And then in the BDS data set, you would just have the planned treatment and actual treatment. And if you would have a crossover design, it would not be as easy as this. You will have to do some further derivations to have the correct intervention period correlating to planned or actual treatment. So this is a typical BDS variable. And this is ADSL, and ADSL you will indicate if it's period 1, intervention period 1 or 2 or more. You can have crossover trials with 4 drugs, with 4 intervention products. Okay, this is just yeah, how to say, a basic an administrative variable, a sequence you want to. This will help to get a unique order, and it's mostly of interest for your XPT that will be created in the end. We had param CD, or the parameter code derived. This is a typo. It should be just a parameter, param, and the numeric version. So I was surprised to see that they were deriving that in the end. And yes, they do use the metadata for this. So how does the metadata look like? Do I have it open? So before we wrap up, we can quickly, let me check if I have the metadata. Oh. Okay. So in this, here you can see that will happen in the wrap-up section with Metacore. Yeah, if you will run an, if you will check the, well, it's also some prop contest, but if you will check the information of the data set, then yeah, this will be reflecting like the length of the variable and what will be the label. And so you don't have to assign these in your program. In SAS, you would do that. This is more of interest for your define XML, so more for submission related information, not really for your data set. But then the code list, that's what's important, because then the recoding happens. Okay, so we would have then weight and height, and this then will be recoded for parameter to a prop case, and then the code weight and height will then it will get 4 and 5. That's the recoding that happens with the metadata, with help of metadata. Okay, that happens here in this step. And then it's time to wrap up. Apparently, base type, ATPT, and D type were required in Metacore. Can I see it here? Yeah, because the key variables are defined here. So actually, because I didn't have base type and ATPT and D type, because D type is more of interest when you impute or log transform things or calculate average or sum. Yeah, not sure what it would be for PMI. It's okay to keep it empty. It's fine, I think. Yeah, I could also drop it
For
here. And then I
BMI,
think,
so for
yeah,
BMI, sorry, if the question is what would be the D type for
yeah,
BMI? Because I would believe that would be left empty. D
yeah,
type is not, D type is a permissible variable, right? So it
yeah.
need not be always. But if there is a special calculation, at least for most of the studies that we did, if the calculation has to be defined, say for example, we use sometimes average, sometimes percentile, sometimes geometric mean or whatever it is done, it is LOCF or the last maximum one carried forward, something special is done, then we do populate dtype and dechange those variables to indicate how it has been derived for FDA. We don't
Yes.
usually mention because BMI is a standard way of deriving it, and we don't have to populate.
Yeah. Yeah, exactly. And we have for Adams, we have control terminology. So if you will work on submissions, this is just a random Google search. I did not. It's important. The date of the control terminology is important, but that's all decided by your company. So you can check here the possible values for D type. And then the Adam IG will also inform you if this list can be extended or not. And it is an extensible code list, so you can add the
Yeah,
sponsor.
it is defined by the statistician, what kind of
Yeah.
imputation you are doing it. So
Yeah.
if there whatever kind of, say for here, see here, right? LOCF is there, SOCF, POCF, all kind of these things, because these are not clear enough if you don't mention it. So that's a thumb rule that we follow, that if there's not obvious enough, then we don't have to populate it.
Yes. Thank you, Fanny. And then what Metacore will do, it will just then indeed what I showed, the type, the length, label, so on, it will be assigned via the metadata here. So this will also, this can be seen in your XPT, but XPT will be transformed in define XML. So an HTML a layout is one of the options. And there you can see this trace this information back. This is what's happening in this step. And this step, what's happening is the variables, these variables will be kept, or it will look for it and it will notify you if variables are missing. So if you don't want to have all these variables, and you, if you don't want a check on all these variables, you need to delete it from here. I didn't do it. That's why I commented the code there, because it would give me all errors. Yeah, but I needed to update the metadata. So that's how the metadata is being used. And with that, yeah, this is what I wanted to share. Yeah, for now.
Yeah, metadata is more like a format catalog.